and welcome to AWS Julie. Today we're continuing a new playlist where we are covering the data engineering fundamentals that you need to understand to help you prepare for the AWS Certified Data Engineer Associate Certification exam. And we're going to pick up where we left off from the last video, and we're going to talk about the second task statement from domain 1, which is to transform and process the data ingested. So far, we have talked about the data generated in our source system. We chose a data store to store the data, and we talked about ingesting the data into that chosen data store. The next step of the data engineering lifecycle is transformation. And up until this stage, your responsibility as a data engineer has been primarily moving the data from one place to another place. But now we have to make that data useful in this transformation stage. Transformation means to change the data from its original form into some other form that can be useful for downstream use cases. If your data does not have the proper transformation, then it will sit inert, not be in a useful form for reports, analysis, machine learning, and more. So what are tools available to turn raw data into something consumable for our downstream stakeholders? Well, there are queries, modeling, and transformation. So let's step back to fundamentals and ask, what is a query? Well, queries are a fundamental part of data engineering, data science, and analysis, and queries help us to retrieve and act on data. So for the exam, ensure you know how queries work. Data modeling is another fundamental, and I've seen a lot of people skip this step. You cannot jump into building data systems without a design and plan to organize your data in a useful way. Your data model should represent the way your data relates to the real world and reflect how your data should be structured and standardized. Ensure you understand the different data models such as conceptual, logical, physical, and normalization. And I also want to recommend understanding different techniques to modeling batch, analytic, data, and data vault too. So let's talk about this a little bit deeper. Online transaction processing, or OLTP, and online analytic processing, OLAP, data modeling and querying are fundamentally different. OLTP is focused on the latest state of your data. Here, the normalization and third normal form are powerful. Also ensure you are optimized for point queries or single user queries. Your query latency will matter. And remember that using common table expressions can sometimes produce extra latency that you don't want. OLAP is focused on the latest state and historical data. Here, the normalization can cause some queries to be slow, but the latency of your queries are tiny matters compared to OLTP. Ensure you are optimized for group by statements across a large number of records, and remember to use common table expressions instead of subqueries every single time. So we have talked about modeling our data and querying that data. So why would we still need to transform our data? What is a transformation that you can think of? Well, my first thought is mapping that data to the correct types. So changing ingested string data into numeric or data types, or maybe putting records into standard formats or removing bad data. There are later stages of transformation that can change the data schema and apply normalization, or even apply large-scale aggregation for reporting or featureize data for machine learning processes. Transforming your data adds the ability to unify and integrate the data. It manipulates, enhances, and saves the data to be used downstream, which increases the value. It adds scalability, reliability, and usually it is more cost-effective. So what are key considerations for the transformation stage? Well, we have the cost and turn on investment, or the associated business value. So for the exam, ensure you understand batch transformations. Here's a question to test your fundamentals, and here's a hint. I answered this question in our last lesson. Does transformation only occur at this transformation stage? No, because sometimes data is transformed in the source or generation stage or as it's being ingested. Let's talk about the way we process and transform data. Raw data is rarely useful in your final data analytics, and this is why we have to ensure that we design and build the data pipelines to help our data analysts create the business insights that they require. This is called data preparation or data wrangling. You can prepare data in multiple ways and use it in multiple analysis. Data preparation can also add calculated fields, apply filters, and change field names or data types. If the data source is on a SQL database, you can also use data preparation to join tables. Alternatively, you can enter a SQL query if you want to work with data from more than one single table. And we mentioned in our last lesson, some of the AWS services and tools for ingestion can also perform light transformations as part of that ingestion process. For example, Amazon Data Firehose can write data out in Parquet format, but heavier transformations might require you to fully optimize your data for a set of analytic tasks and different data consumers. Data preparation is a core component of our data processing phase. Services that can perform data preparation include Amazon Kinesis, Amazon EMR, and AWS Glue. For the exam, ensure you understand the differences between these services. Amazon EMR is a fully featured distributed Hadoop environment. Its ability to perform transformations goes way beyond what AWS Glue alone can accomplish. AWS Glue is a fully managed ETL service where Amazon EMR is not. Amazon EMR requires the installation of additional frameworks and software such as Spark, Hive, Pig, HBase, and Presto. But AWS Glue is a great solution when all you need is data cleansing, enrichment, and data movement. In our fundamental lesson, I said as a data engineer, you must incorporate security, data management, data operations, data architect, orchestration, and software engineering to manage the whole data lifecycle. Transformations rely on orchestration, and orchestration combines different operations such as intermediate transformations and transformation pipelines that can span multiple tables, data sets, and systems. Transformations can update schemas, wrangle your data, update patterns, and more. Ensure you understand those as well as streaming transformation and processing, and also ensure you can understand when to choose which service for processing and ETL workloads. This task statement also covers key parts of the processing phase of the data analysis pipeline, including the basis of data preparation, curation, and enrichment. Be sure you take the time to really understand the key differences in processing solutions and what indicates the use of one over the other. For the exam, also ensure you know how to connect to different data sources such as Java database connectivity and Open Database connectivity. JDBC is a Java API for connecting and interacting with relational databases. In AWS, to connect to a data source using JDBC, you first prepare the JDBC driver for the specific database you want to connect to. Next, you configure the needed security groups with inbound rules to access the necessary ports for that database. For example, for MySQL, you would allow inbound access to port 3306. Then, in your Java application, use the JDBC driver to establish a connection to the database by providing the appropriate connection URL, username, and password. The connection URL typically includes the database hostname or IP address, port number, and database name. After the connection is established, you can use JDBC APIs to execute SQL statements, perform queries, updates, and other database operations. ODBC is a standardized API for connecting to various data sources, including relational databases. First, you select an ODBC driver that corresponds to the data source you're connecting to. Then, install the ODBC driver on the system you'll be connecting to the data source, which might be an EC2 instance or an on-premises server. Then, set up ODBC data source name that contains the necessary configuration information for connecting to the data source. This includes the driver, connection details, such as hostname, port, and authentication, and other settings too. Then in your application or tool that supports ODBC connectivity, you specify the DSN to establish a connection to the data source. You can then execute queries and interact with the data. However, Amazon RDS, Amazon Aurora, or Amazon Redshift helps to simplify this process of connecting to the database within AWS and to the AWS services, and they provide direct connectivity options and automated management, which reduces the need for manual JDBC or ODBC configurations. Ensure you understand how to choose the appropriate connectivity method based on the data source you're working with and the specific requirements of your AWS environment. Let's wrap up this lesson and talk about creating data APIs to make data available to other systems by using AWS services. For the exam, ensure you understand how to use a combination of AWS services and techniques. And we've covered this a bit already. First, know where the data is stored. AWS database services are Amazon RDS and more. If you need to perform data processing or transformations, AWS provides AWS Glue or Amazon EMR to help you cleanse, normalize, and transform the data into a usable format. You can use Amazon API Gateway to create and manage APIs for your data. API Gateway acts as a front-end service that enables clients to access your data securely and with controlled access. It provides authentication, authorization, rate limiting, caching, and request response transformations. And AWS Lambda can be used to process and serve the data for your API. You can write code in Lambda to fetch the data from the data source, apply any additional transformations, and respond to those API requests with the formatted data. Also, Lambda can be triggered by API Gateway or other AWS services based on your requirements. What about security and authentication? Well, you can implement security measures to protect your data API using AWS IAM to control access and permissions for API Gateway and your Lambda functions. You could also use AWS Certificate Manager, API keys, OAuth, and other authentication mechanisms to secure your API endpoints. What AWS services could you use for caching and performance optimization? Well, to improve the performance of your data API, you can use Amazon Elasticache or API Gateway's built-in caching features to cache responses and reduce latency. You can use Amazon CloudWatch to monitor and track the performance, latency, and usage of your data API, and you can configure logging to capture API request logs and errors for troubleshooting and analysis. API Gateway could be used to version your APIs and to manage changes and maintain backward compatibility. For scaling and high availability, you can use auto-scaling for your Lambda functions and configure API Gateway to handle high concurrency and availability requirements. For testing and validation, you can use AWS Code Pipeline and AWS Code Build for continuous integration and deployment to automate the testing and deployment process. For the exam, ensure you know the different AWS services to use to create secure and scalable data APIs and make your data available to other systems. Let's move on and talk about the third task statement from Domain 1, which is to orchestrate our data pipelines. Under our fundamentals lessons, we mentioned data architecture must be incorporated to manage the data lifecycle. Data architecture is basically the design of your systems to support the evolving data needs of your organizations. There are operational and technical aspects that need to be considered. Operational architecture is the functional requirements. The technical architecture is how the data is ingested, stored, transformed, and served. For more depth on building optimal data architectures, check out the AWS Well-Architected Framework and the 6 pillars. Here are a few questions. Do you use monolithic or microservices? What are your considerations for single versus multi-tenant? Well, I always think of performance and security first, but what about event-driven architectures or serverless or containers? Control, flexibility, and cost are also really important. For the exam, ensure you know examples and types of data architectures such as data warehouses, data lakes, data stacks, Lambda, data mesh, and more. From these different data architectures, a data pipeline can be built to bring data in from your source systems and then transform that data, which often includes multiple different stages, further transforming or enriching the data as it flows through each stage of your data pipeline. You may have tens or hundreds of pipelines working independently or in conjunction with each other on different data sets and also perform different data types of transformations. Each pipeline may use multiple services to meet the requirements and goals, and orchestrating all of these services and pipelines can be complex. But AWS provides services to help with orchestrating your data pipeline. When you're designing your workflow, ensure you design the steps and the dependencies, and when needed, use smaller tasks or stages that can run independently. Data orchestration is the process of ensuring that data flows properly from the ingestion service into the processing services and then out to the storage location. For this exam, ensure you understand the core concepts for pipeline orchestration. Can you define a data pipeline? It is a collection of data processing tasks that need to be run in a specific order. Some of the tasks need to be run sequentially, but others may need to run in parallel. And the sequencing of the task is that workflow. What is a serverless AWS service for orchestration? Well, we have AWS Step Functions and AWS Lambda, and you could use the state machine language in Step Functions to design states, transitions, error handling, retries, inputs, outputs, event source, the triggers, monitoring, logging, testing, and deployments. Data pipeline orchestration also involves automating the execution of tasks for the data pipeline workflow, which includes managing any dependencies between different tasks and ensuring that that pipeline is running as expected. And one really important part of our pipeline and configuration of how you build your pipelines is how you handle the failure of a step in that pipeline. What are a few common reasons for failures in your data pipeline? Well, there are data quality issues, such as if your pipeline is expecting to receive CSV files to process, but instead your pipeline receives a file in JSON format. Well, your pipeline does not know how to process that JSON formatted file. So this would cause a failure, probably a hard failure, since your job cannot recover until that data quality issue is resolved. There could also be code errors, and we'll dive deeper into applying programming concepts in our next lesson. But let's say you update a job and accidentally introduce a logic or syntax error into your code. Sometimes, and I do this often, even if you test your code before deployment, it may not catch a specific error, but testing your code is always best practice before that deployment. This would also cause a hard failure because you would need to fix your code and then redeploy. There could also be endpoint errors, and if the endpoint error is due to a temporary network error, this would be a soft failure because by retrying that connection, it could fix the error. But maybe your job is not configured with the correct and needed permissions, then that would be a hard failure. And there are also dependency errors because the data pipeline consists of different multiple steps and complex dependencies. This could be a dependency within your pipeline or between pipelines. So how do you orchestrate your pipeline with failure retry strategies? Many orchestration tools such as Apache Airflow or AWS Step Functions give you that ability to specify the number of retries, the intervals between retry attempts, and back-off rate too. Let's look at an example of how this would work with AWS Step Functions. You could specify a back-off rate value that will multiply the delay between retries by that value. Let's say that I specify a retry interval of 10 seconds and a back-off rate of 1.5. Step Functions will wait 10 seconds. Then for the second retry, Step Functions will wait 15 seconds, which is 10 seconds times 1.5. For the third retry, Step Functions will wait 22.5 seconds, which is 15 seconds times 1.5, and then it continues. How can you use AWS notification services to send alerts for any issues or failures? Well, monitoring and notifications is an integral part of our automation process for our data pipelines. So let's jump back to the step function example we were just talking about with retries. If there's a failure in your state machine, you can configure an email notification to be sent to alert you or the team of that failure. You can use Amazon's simple notification service to send an email. And for your exam, dive deeper, ensure you know how to create an SNS topic and subscribe one or more email addresses to that topic. We'll be covering alerting and monitoring in more detail as we continue on throughout this playlist, but especially under Domain 3, which is data operations and support. Let's dive back into our AWS services for orchestrating data pipelines. There are serverless orchestration engines with AWS Data Pipeline and AWS Step Functions. There is a managed open source project with Amazon Managed Workflows for Apache Workflow and service-specific orchestration with AWS Glue workflows. For the exam, know when to use each of these solutions for different use cases, requirements, management effort, integration effort, logging, error handling, and performance, which also includes performance and cost. For the exam, dive deeper into AWS Step Functions and know the different use cases, requirements, and integrations. For this exam, you will also need to know which orchestration pipeline tool to use. For less complex environments, would you choose AWS Data Pipeline or AWS Step Functions? I would choose AWS Data Pipeline for less complex environments and AWS Step Functions for more complex environments. Let's look more at AWS services for less complex and more complex environments. AWS Glue Workflows is a great choice if your data pipeline only uses AWS Glue components. AWS Glue Workflow is part of the AWS Glue service to build your data pipelines, and it gives you the ability to use the AWS Glue console to create, visualize, and run your workloads. With AWS Glue Workflows, you can build out the workflow by adding triggers to the workflow graph and defining the watched events and actions for each trigger. For the exam, ensure you know how to build a data pipeline for performance, availability, scalability, resilience, and fault tolerance. We've mentioned this a few times already, but let's quickly cover a few best practices. Use distributed processing frameworks such as Apache Spark, Amazon EMR, or AWS Glue to handle large volumes of data and parallel processing across a cluster of resources. Configure auto-scaling in your data pipeline to ensure optimal performance and cost efficiency. Implement proper data partitioning techniques to distribute data across multiple processing resources. Use fault-tolerant storage services such as Amazon S3 or Amazon EFS for storing your data. Implement backups, strategies, and plans to protect your data with Amazon S3 or AWS Backup to ensure data availability to help with disaster recovery. Use Amazon CloudWatch to monitor the health and performance of your data pipeline. Set up alarms. Ensure you understand how to set up alarms and notifications to actively detect and respond to issues, implement error handling and retry mechanisms within your data pipeline with AWS Step Functions or AWS Glue workflows, implement data validation and quality checks and include automated testing, version control, and deployment processes. Isolate different stages or components of your data pipeline into units for troubleshooting, maintenance, and scalability. You can use AWS Lambda, AWS Glue, or containerization technologies to encapsulate and isolate individual data processing components and implement CI/CD practices for your data pipeline to ensure efficient deployment of all changes. Now, in our next lesson, we're going to wrap up Domain 1, and we're going to talk about the fourth task statement from Domain 1, which is applying programming concepts.